Okay, now it's time to look at whole number arithmetic. Let's get started. All right, so now we're going to try adding like they did in ancient times, okay? So in order to help out with this, I've got some sunflower seeds here. Should make things easy. All right, I want to add 8 and 5, and let's say that I've never been educated because school is not a thing that has been invented yet, but I need to do some trading with someone and I need to know, okay, I have 8 things and 5 more things. How many things is that? And I don't want to actually go pick up all those things. I can use sunflower seeds, for example, as a substitute for those things. So I put 8 sunflower seeds up there, and I put 5 sunflower seeds here, okay, or parts of sunflower seeds, whatever. All right, and then if we add those up, I can just count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 8 plus 5 is 13. No surprises. Okay, good. So now the question is, okay, that's all well and good, but what happens if I have, say, 58 plus 5? Well, I'm glad you asked. So I can now put, so my 8 sunflower seeds go up there, and I have 5 sunflower seeds here, and now I'm going to put 1, 2, 3, 4, 5 sunflower seeds here to represent that 5 of 50. And so what we do now is collect up the sunflower seeds here and then take away 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And those will become part of this group. So this is the process that we would call carrying the 1. So this extra sunflower seed goes up here, right? Because each of these sunflower seeds is representing 10 units, right? So this sunflower seed I'm going to put up on this column is representing 10 units. Okay, so I can take these 10, put them back in here. And so now, how many sunflower seeds do I have in my 10s units? I have 1, 2, 3, 4, 5, 6. So what I'd end up with there is 63. Okay, but that's not all. What about a bigger number? What if I said, let's make this 358 plus 25? Well, the answer won't be 63. What will the answer be? Well, okay. So in ancient times, right, they would have used these sunflower seeds and done all this, but what hopefully you're starting to see is we don't actually need to use the sunflower seeds if we can remember how to add single digits together. That's all we need. So what you need to do, if you haven't done this yet, and hopefully you have, but you need to learn all of the sums of single digits and learn them off by heart. Okay? That is your job in this course. You need to have that done. Okay? So that is your homework. If you haven't done it back when you were younger, you now need to practice that, okay? And have it so that it's very quick. All right, so now let's do this. We know that 8 plus 5 is 13. Okay, and so we put the 3 down here and carry the 1, because that was 3 and 1 10, right? And then, okay, we take 5 and 2 is 7, and then we add 1 more, because we carried that 1, to get 8. Okay, and then how many hundreds are there? Well, there's 0 hundreds here, plus 3 hundreds, and we didn't have to carry any, so this 3 is all of the hundreds that there are. So this became 3 hundreds, 8 tens, so 80, and 3. So 383 is our answer. That is how we do addition. Okay, I'll do one more example with a bigger number in just a moment. Okay, here we go. 1,992 plus 378. How do we do this? Well, remember, we're always going to start with the smaller numbers and build our way up. So we start with 2 plus 8. 2 plus 8 is 10. So we put a 0 and carry the 1. And so now we're done with the units. Now we look, okay, 1 plus 9, that's 10, but then we also have to add the 7, so that gives me 17. All right, cool. Once again, 1 plus 9 is 10, plus the 3, so that's a 13. And now we've carried a 1 over, and we have 1 plus 1 is 2. So what we've got now is 1,992 plus 378 is 2,370. Okay. So that's addition for you. There will be lots of practice, and the idea here is that you're going to go practice this. I will give you some practice that I'll be posting on Blackboard, and we will be doing the practice in class. Okay, we want to get very, very fast at this, because the idea is that your first test is going to be done without a calculator, okay, and your tests when you are actually in the nursing program, you'll need to be able to do arithmetic without a calculator, so be ready for that. Okay, next we're going to move on to subtraction, so just a moment. Okay, here we go. 1,992 plus 378. How do we do this? Well, remember, we're always going to start with the smaller numbers and build our way up. So we start with 2 plus 8. 2 plus 8 is 10. So we put a 0 and carry the 1. And so now we're done with the units. Now we look, okay, 1 plus 9, that's 10, but then we also have to add the 7, so that gives me 17. All right, cool. Once again, 1 plus 9 is 10, plus the 3, so that's a 13. And now we've carried a 1 over, and we have 1 plus 1 is 2. So what we've got now is 1,992 plus 378 is 2,370. Okay. So that's addition for you. There will be lots of practice, and the idea here is that you're going to go practice this. I will give you some practice that I'll be posting on Blackboard, and we will be doing the practice in class. Okay, we want to get very, very fast at this, because the idea is that your first test is going to be done without a calculator, okay, and your tests when you are actually in the nursing program, you'll need to be able to do arithmetic without a calculator, so be ready for that. Okay, next we're going to move on to subtraction, so just a moment. All right, so now let's take a look at subtracting. We're not going to use the sunflower seeds for this. We can do this in our heads, well, or at least our heads in the paper. So we're going to start with 0 minus 8. We start with the units. We have a problem though, because I can't take 8 away from 0. There's nothing to take away. So am I stuck? No, I'm not stuck. What I can do is I can borrow from the 2. So just like I would take one sunflower seed and it would magically turn into 10, I'm going to borrow 1 from the 2, and then this, rather than being 0, becomes 10, right? So this is now 10 minus 8, and that I can do. It's 2. Okay, cool. Moving on to the next column. Now, I don't have a 2 here anymore, I have a 1. So I have 1 minus 5. Can I do that? No, 1 is too small to take 5 away from it. So what do I have to do? I have to, once again, borrow. So this 1 goes away, and it becomes a 0, I suppose. And then up here we have 11, and then 11 minus 5, that's something we can do now. So we have 6. So there we go. 120 minus 58 is 62. That's how we do subtraction. Okay, I'll do one more example. All right, and then we'll move on to multiplication. So here we go. Okay, so last example of subtraction here. The one thing that we need to worry about is, hey, what happens if we have a bunch of zeros when we need to borrow? So if we look at our first situation, okay, I have 0 minus 8, and I can't do that because I can't take 8 away from 0. All right, so far we're not talking about negative numbers. We'll get to negative numbers eventually, folks. Okay, but when we're talking about this subtraction algorithm, we're not thinking of negative numbers. So 0 minus 8, can't do it. All right, so I would need to borrow. Oh, okay, so I look to the next level up. Hey, can I borrow anything from the tens column? Hey, tens column, you got anything? No, the tens column is also broke. So the tens column then says, okay, I need to borrow myself, so the tens column goes up to the hundreds column and asks, hey, you got anything? And the hundreds column is like, no man, I'm broke too. So the hundreds column then looks up to the thousands column, and thank goodness there is something there to borrow from. So we're going to borrow 1 from the thousands column, so we're borrowing 1 from 2, so that leaves us with 1 here, and then that makes this a 10. Okay, but remember, the hundreds column is going to borrow from the tens column is going to borrow from the hundreds column. So we need to borrow from this 10. 1 minus 10 is 9, so we're borrowing it. And it comes down here. And then we have 10, and we need to borrow that 1 from there. All right, so that gives us 9. And lastly, now we have 10 units. Okay, so now that creates a bunch of 9s that we'll have to deal with, but let's do this now. We've got 10 minus 8, and I can now do this. So 10 minus 8 is 2, and now we can go through everything else. 9 minus 5, that is doable. It's 4. 9 minus 1 is doable. It's 8. 1 minus, now there's nothing written here, but remember, nothing is just another way of saying 0, right? There's 0 in the thousands column, right? There's nothing in the thousands column. So 1 minus nothing is 1, and 3 minus nothing is 3, leaving us with 31,842. All right? So now you have everything you need to go practice some subtraction. Enjoy. Next up, multiplication. Okay, let's talk about multiplication. Let's start with a very basic question. Let's start with something like 3 times 5. Okay, well, hopefully this one you know off by heart is 15, but how would say that, if we went back 10,000 years or so, how would people have to figure this out? Well, first off, what does it mean? 3 times 5, that means either it means 5 threes, or it means 3 fives. Let's do it as 3 fives. So we're going to use the sunflower seeds again. So there's a 5, and I need 3 of them. So let's put another one down. There's 3 and 2 more. So that's another 5. And then, here we go. Putting down another 5. So here we go. We now have 3 5s. And if we count these up, we will see there's indeed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 sunflower seeds. So 3 times 5 is 15. Okay, so the reason I'm starting out here is to emphasize that single-digit multiplication, there's no trick for other than just you have to learn the multiplication table. There are tricks for individual pairs of numbers. There's the trick with the 9 times table, for example. So if I had, say, 9 times 6, what you do is you put down your 6th finger, which, so 1, 2, 3, 4, 5, 6, so this one, and then you look okay, at your two hands, and we have 5 and 4 fingers. So in that case, 9 times 6 is 54. Okay, let's try that one more time for the 9 times table. If I had 9 times, say, 8, I'm going to put down my 1, 2, 3, 4, 5, 6, 7, 8th finger. So put it down like that and see, okay, so this is now the break. On this side I have 7 fingers, and on this side I have 2 fingers. So 9 times 8 is 72. Now, this only works when we're multiplying by 9. Okay, so this is one of those tricks. It's a nice trick for multiplying by 9. There are tricks for other numbers. Multiplying by 2 is pretty easy because it's just adding, right? But I'm not going to teach all of those tricks right now. I might mention those in class for some of them. Okay, but it is your responsibility to know how to multiply single digits, okay? So if you have to draw things out like this, it will take a long time, so I suggest that you practice and start memorizing your multiplication table. And this is one of the rare times where I will use the M word of memorization. I don't like talking about memorizing in math, okay, but sometimes with the multiplication table, to make things quick, it's just best to do that. Okay, let's kick it up a notch and look at what is basically the same question. But let's now say 30 times 50. Okay, so 30 times 50 rather than 3 times 5. Well, what does that mean? Well, what I can do now is say that each of these single sunflower seeds, each of these single sunflower seeds represents 10, but it doesn't quite work that way. It represents 10 in this direction and 10 in this direction. So we have 10, 20, 30, 40, 50 going in this direction, and 10, 20, 30 going in this direction could be one way of looking at it. Okay, but in that case, one sunflower seed is really representing 10 sunflower seeds in one direction. Of course, well, I could just put them all out, but no, I'm scrapping that idea. Instead, I'm just going to use the fact that I have graph paper here, and that will make things a lot nicer. If I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, if I have a 10 by 10 grid like this, if this is 10 and this is 10, then of course, let's see, did I count that right? Yep. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I went too far. Okay, so if I have a 10 by 10 grid, then how many squares do I have? I've got 1, 2, 3, 4, 98, 99, 100. So there's 100 squares, right? And that's not surprising. That goes back to how the decimal system of numbers works, right? If I take 10 tens, that makes the next step up in the system. So we have 100. Okay, cool. So what happens here? Well, that means that each of these individual, what am I saying here? That means that each of these individual sunflower seeds actually represents 100 sunflower seeds now, if I'm talking about 30 times 50. So 30 times 50. So that means I have 1, 2, 3, 4, 5, 6, 1,500. So that's 1,500 is my answer. So okay, so how did I do that? Well, let's now look at what would happen if I had a unit something in the units column. So let's look at, let's say 35 times 50. Okay, so to do this, what am I going to do? Well, is this what I want to do? You know what? No. I want to rearrange that just so that for teaching reasons, because I would rather have the units in the bottom. So let's try that again. So I'm going to have 50 times 35. Okay, so what I'm going to do now is say, all right, that's going to be 5 50s, okay, and then 30 50s. Okay, so let me just write down what I said there. That is 5 times 50 and 30 times 50, right? Okay, so what is 5 times 50? Well, I know that, so 5 is just units, so when I multiply 5 times 50, I'm going to get just 5, well, 50 plus 50 is 50, so it's the same as 5 times 5, and then a 0 at the end, right? So that becomes 250. So I have 5 times 50 is 250. And then 30 times 50, what does that end up being? Well, 30 times 50, I know what that is already. It is 1,500. So I add those numbers together to get my whole answer. So 0 plus 0 is 0, 5 plus 0 is 5, 2 plus 5 is 7, and 1 plus nothing is 1. So I get 1,750, or 1,750 is the answer there. So that should be a comma. There we go. All right. So now, what if I had a number in the units column for 50? So let's say this is 52 times 35. Okay, we're going to do the same thing as before. I'm now going to say, okay, 5 times 52, that's going to be the number that goes here. Okay, so what is 5 times 52? Well, okay, hang on. We can break this up even more. 5 times 52, that's going to be 5 times 50 and 5 times 2. Okay, so 5 times 50, right? That's the 250 that we had before, and 5 times 2 is 10. So let's write that down, starting from this side. 5 times 2 is 10. Okay, so there's going to be a 0, and then we're going to add that to this 5 times 50. So 5 times 50 is 10. Carry the 1. 5 times 5 is 25, plus 1 is 26. So 5 times 52 is 260. Okay, hopefully you're following. Now, let's now say the next step is going to be 30 times 52. Okay, well, same idea as before, as what we did up here. This is 30 times 50 plus 30 times 2. So what I'm going to do now is take this 3, which really represents 30, and multiply it times 2. Well, 3 times 2 is 6. 30 times 2 is 60, right? So what we often do is just say, hey, put a 0 here because I'm multiplying by a factor of, well, this is really 30, so it's a factor of 10, so there will be a 0 here. And now we can just think of this as a 3. So this is 3 times 2, okay, and that is 6. And then 3 times 5. Notice this 1 was from before, so I don't think about this now. So 3 times 5 is 15. So that's the 1,500 that we had before of the 30 times 50, so from over here, plus the 5 times 2, sorry, not the 5 times 2, the 30 times 2 that we have here. Okay, so Now we add all this together. 0 plus 0 is once again 0. 6 plus 6, that is 12. So we're going to put a 2 carry the 1, just because this is adding like we've done before. And then 1 plus 2 is 3, plus 5 is 8, and then we have a 1. So 52 times 35 is 1,820. Okay. All right. So let's do a few more multiplication examples for practice. Okay. All right, and we won't worry so much about breaking things down, and we'll worry about just handling it with the algorithm. All right. So here we go. Okay, so here we go. We're going to multiply a 4-digit number times a 3-digit number. Okay, and we're going to write down the steps that we need to do. Okay, so like with addition and subtraction, the first thing that you need to remember is that you start on the right. Okay, so we're starting with the units column. So we're going to start here. Okay, and what we're going to do is we're going to take our units, so the 7, and multiply it by the upper number. And then we're going to take the tens column, so which is going to be 20, right? This 2 represents 20, and multiply it by the upper number. And then we're going to take the hundreds column, so 700, and multiply it by this upper number, and write all those down, and then add them all together, and that will be our solution. So here we go. Let me write down the next step that we're about to do. We're going to take the lower number unit times the upper number. Okay, so here we go. 7 times 8 is, well, let me think. 8 times 8 is 64. Let's subtract 8 from that to get 56. So we write down 6, and the 5 gets carried up here, right? Because it's 6 units and 5 tens. So we need to remember, okay, 5 tens. Now, 7 times 5, that's 35, but then we add 5 because we have another 5 tens. So remember what's really happening here is I have 7 times 50, which is 350, plus another 50 to get 400, but we often just think of it as 40 tens. That makes any sense. So we've got 40 tens, okay, and now the next one, 7 times 2 hundreds, right? Well, 7 times 2 is 14, and then plus 4 more hundreds that we have left over from our other working out. So 7 times 2 is 14, plus 4 is 18. And then 7 times 1,000 is, of course, 7,000, but then we've got another 1,000 left over, so that gets us 8,000. So 7 times 1,258 is 8,806. Okay, so that's great. So now step 3 is just going to be the same step, pretty much, but the lower number tens space times the upper number. So remember, this is saying 727. So what I'm looking at now is I'm going to multiply by 20. So I'm multiplying by 20. So if I multiply anything that is a factor of 100, factor of 10, if I multiply anything with a factor of 10, there will be a 0. That we begin with, and then it's just a matter of multiplying by 2. So we have 2 times 8. Okay, well, 2 times 8 is 16. Now, we're going to carry the 1. Notice these numbers up here, that was from carrying when we were multiplying by 7. We don't need those numbers anymore. They are not useful. So now we're on a new mission. So 2 times 8 is 16, carry the 1. And now 2 times 5 is 10 plus 1 is 11, right? 2 times 2 is 4. Hold on, where was I? 11, I forgot to carry the 1. Be careful, okay? Things like this is how we make mistakes. So 2 times 8 is 16. 2 times 5 is 10 plus 1 is 11. 2 times 2 is 4 plus 1 is 5. And 2 times 1 is 2. Okay, so what I've just done there, 20 times 1,258 is 25,160. That's where we're at so far. And now last thing, I'm going to multiply by 700, right? So rather than saying, oh, you know, do the hundreds and the thousands or whatever, I'm just going to write an and so on, ... right? Just each successive, right? But remember, this is 700, so I need to put in 2 zeros, right? Because when I multiply by 100, there will always be 2 zeros at the in the units and the tens column. So now, 7 times 8, well, notice I've already multiplied 1,258 by 7 before. So sometimes we get lucky and we can do that and say, hey, I already know what this number is going to be. It's going to be, well, 6088 in reverse order, so 6088 like that. So that means that 700 times 1,258 is, let's see, 880,600. Okay, cool. So now what I've got here, I've got 700 times the number, 20 times the number, and 7 times the number. If I add them up, I will get 727 times the number. So let's do that. 6 plus 0 plus 0 is 6. 0 plus 6 plus 0 is 6. 8 plus 1 plus 6. Well, 8 plus 1 is 9, plus 6 is 15, carrying the 1. 8 plus 5 plus 1, so that is 14. Let's see, 2 plus 8 is 10, plus 1 is 11, and 8 plus 1 is 9. So 727 times 1,258 is 914,566. And that is how we multiply large numbers. Okay, let's talk about division now. Division is the undoing of multiplication. So if I ask you a question, hey, 172, let's say, divided by 2 is equal to what? That's the same thing as saying, hey, what number, when I multiply it by 2, will get me 172? That's the question that I am asking. Okay, and so what I'm going to start with is just how do we do division when it's nice and simple numbers like 2. Okay, there's some easy ways of doing division rather than resorting to long division, which I will be getting to because not every number is as nice as 2. Okay, but if you have a number like 2 and we're dividing, say, 172 by 2, some of you I'm sure have already got the answer, which is good. But let's get through this. What you can do is just go through the number, break it into pieces. So we're going to take this 172 and say, well, I could think of that as 170 and 2. Okay, and then what I can do is just divide each of those pieces into 2, or by 2, and then add them up. So 100 divided by 2, that's 50. And 70 divided by 2, well, half of 7 is 3.5, so half of 70 is 35, right? So half of 70 is 35, and then 2 divided by 2 is 1. Hopefully that's not a surprise for anyone. And then if we add all those up, I have 5 plus 1 is 6, and 5 plus 3 is 8. So the answer, 172 divided by 2, is equal to 86. Okay, now that works really well for 2 because 2 goes evenly into 10 and 10 is the base that we work in. What if instead I was to ask, okay, 100 and let's say 74 divided by 3. What is that? Okay, well, it's still asking the question, okay, I need to take a number and multiply it by 3 and get 174, and I'm going to try and do this the same way, but I need to be a little bit craftier. I need to come up with numbers that I know 3 goes into, that I can break up and try and get them so that they add up to 174. So let's see. What's the biggest number I know 3 goes into evenly? Well, one thing I could do, let's say 99. I know that 3 definitely goes into 99 because 3 goes into 9. So I could say, all right, 174 is equal to 99 plus, well, what's left over? So 174 minus 99 is, well, 4 minus 9, can't do it, gotta borrow. So 14 minus 9, that's 5. 6 minus 9, can't do it, gotta borrow. 16 minus 9 is 7. Okay, so 99 plus 75 is 174. So I could say, all right, so 174 divided by 3, that's the same as saying 99 divided by 3 and 75 divided by 3. And those numbers I can do pretty easily. 99 divided by 3 is just 33, and 75 divided by 3, for anyone who's worked with money, right, 3/4 is 75 cents, so this is just 25. So I can add those up to get my answer. So 3 plus 5 is 8, and 3 plus 2 is 5. And so what I have then is 174 divided by 3 is equal to 58. Now, what if you're not feeling so confident? Let's just check our work to make sure. Well, how do we check our work? Well, we can go back and say, hey, what is 58 times 3? It should be 174, but let's try it. 3 times 8 is 24, so that's 4, carry the 2. 3 times 5 is 15, plus 2 is 17. So that is 174 as expected. So there we go. We've just done some simple division. And so you can practice this with a few other examples. Right, and this is just so that we can do division quickly, and quickly and in our head, or at least quickly on a piece of paper without having to resort to long division. Sometimes we're going to have to, but we're going to just do a few more simple ones. What if I wanted to, say, take, I don't know, 100 and, I don't know, let's say 96. 196, and I want to divide this by 4. Okay? What does that equal? Well, once again, I'm going to break this up into numbers that I know I can divide easily by 4. So I know that 4 times 4 is 16, so let's do 160. So I can say, hey, 196 is equal to 160 plus something. What is it? Well, 196 minus 160 is, well, 6 minus 0 is 6, 9 minus 6 is 3, and 1 minus 1 is 0. So 160 plus 36, right? So 196 divided by 4, that's the same as saying 160 divided by 4 and 36 divided by 4, and then just add those two numbers up. Okay, 160 divided by 4, I can do that, right? Because 4 times 4 is 16, so 160 divided by 4 is got to be, well, it's got to be 4 times 40 to get to 116, right? So this is going to be 40, right? And 36 divided by 4 is, well, okay, can we do that? If you're good, hopefully you recognize, hey, 4 times 9 is 36, so the answer here is going to be 9. Let's say that wasn't so easy, then we could break this down even further and say, hey, 36, we could say, okay, 36 is equal to 16 plus 20, right? All right, and we could say, well, 16 divided by 4, right, is 4. 20 divided by 4 is 5. 4 plus 5 is 9. So, as I said, so there we go. So we can do some fast division this way. Notice when I say fast division, I'm doing a lot of writing down here because I'm explaining it to you. These are things that you could do just chicken scratch. You do not have to show all of this on a test at all. If you can do it in your head, more power to you, okay? But if you're worried about making mistakes, okay, then writing a bit of chicken scratch somewhere, just your workings out, that's fine, okay? Remember, the test, we don't have a calculator, so you need to have some methods of doing these things and ideally doing them quickly. All right, so back to the question, 196 divided by 4, well, you just take these two numbers and add them together, we get 49, so 196 divided by 4 is equal to 49. Okay, let's check our work real quick just to make sure. Okay, once again, on a test, okay, I won't be marking whether or not you check your work. Okay, I won't mark whether you check your work. However, if you check your work, you'll know you're right and get more marks that way. So it's a good practice to get into. But let's do this real quick. 4 times 9 is, oh, well, hold on, this is a nines thing, so I can use my nines trick. I can put down 4, my fourth digit here, my fourth finger, and so it's 36. Okay, cool. So that's 6 there, and 3 that carries, and then 4 times 4 is 16, plus 3 is 96. Notice, as we did that, I had 36 plus 160 kind of showed up as I was multiplying, and those were the numbers that showed up here. Isn't that interesting? There's probably something to that, isn't there? Anyway, so yeah, we can always take the numbers that we're dividing and break them down into smaller numbers that are easier to divide, and then add them back up to get our answer. In this case, it was 49. So there you go. There's hopefully a useful trick for division. Next up, long division. What happens when you don't see the useful tricks, or if there are no useful tricks? Okay, long division is how we can do division in the worst weather. Here we go. All right, and that's whole number arithmetic done. So we can check that off. We did adding, subtracting, multiplying, and dividing, or at least short division. And now on to long division.